We humans are, well, a curious species. We are driven by a thirst for knowledge, and what could be more fundamental to our quest for understanding than awe? Awe is that feeling of being in the presence of something vast and mysterious. Think about standing at the edge of the Grand Canyon. Imagine gazing up at a star-filled night sky. These experiences fill us with a sense of wonder. Awe is more than just a fleeting emotion. It is a complex neurophysiological phenomenon. It involves profound changes in our brain activity. These changes have a significant impact on how we think, feel, and behave. One of the most striking findings in the neuroscience of awe is the deactivation of the default mode network, or DMN. When we experience awe, the DMN quiets down. We become less self-focused. This deactivation is thought to reduce stress and anxiety. Awe pulls us out of ourselves. Our attention shifts to the world around us. Studies show that people who experience awe report higher well-being. Cultivating awe could improve our overall well-being. While the DMN is deactivated during awe, other areas of the brain light up. One of these areas is the prefrontal cortex, or PFC. The PFC is responsible for higher-level cognitive functions. These include planning, decision-making, and abstract thought. The activation of the PFC during awe suggests that this emotion is not just about feeling small, it's also about engaging with the world in a more thoughtful and analytical way. When we experience awe, our sense of self expands. We begin to see ourselves as part of something much larger than ourselves. This expanded sense of self is accompanied by an increased capacity for perspective-taking. We are better able to understand the viewpoints of others. We are more likely to act in prosocial ways. The activation of the PFC during awe may also explain why this emotion is so effective at promoting learning and creativity. When we are in a state of awe, we are more open to new information. We are more likely to make connections between seemingly disparate ideas. This makes awe a valuable tool for anyone who wants to learn, grow, and expand their understanding of the world. Another brain region that plays a crucial role in awe is the salience network. This network is responsible for detecting and orienting us to salient stimuli in our environment. It helps us determine what is worthy of our attention. When we experience awe, the salience network is activated. This suggests that our brains are recognizing the experience as something significant and meaningful. The salience network is also involved in our perception of novelty. Awe-inspiring experiences are often novel and unexpected. They challenge our existing schemas and force us to update our understanding of the world. This process of cognitive accommodation is essential for learning and growth. The activation of the salience network during awe may also explain why this emotion is so contagious. When we see someone else experiencing awe, our own brains are primed to experience it as well. This shared experience of awe can create a sense of connection and belonging. It can inspire us to work together to achieve common goals. The experience of awe is not just limited to changes in brain activity. It is also accompanied by a cascade of neurochemical changes. These changes further enhance and reinforce the effects of awe on our brains and bodies. One of the key neurochemicals involved in awe is dopamine. Dopamine is often referred to as the feel-good neurotransmitter. It is associated with pleasure, reward, and motivation. When we experience awe, our brains release dopamine. This gives us a sense of pleasure and reinforces the behavior that led to the awe-inspiring experience. In addition to dopamine, awe also triggers the release of oxytocin. Oxytocin is often called the cuddle hormone because it is released during social bonding activities like hugging and kissing. Oxytocin promotes feelings of trust, empathy, and connection. This release of oxytocin during awe may explain why this emotion often leads to a sense of connectedness with something larger than ourselves. Awe also influences the production of serotonin. Serotonin plays a crucial role in regulating mood, sleep, and appetite. It contributes to feelings of well-being and happiness. By boosting serotonin levels, awe can have long-lasting positive effects on our mood and overall mental health. Brainwave activity also shifts dramatically during awe. Researchers have observed a significant increase in theta wave activity when individuals experience awe. Theta waves are associated with states of deep relaxation, meditation, and creativity. they are also linked to increased receptivity to new information and enhanced learning. This surge in theta wave activity may explain why awe can lead to feelings of transcendence and spiritual connection. It may also contribute to the sense of timelessness, often reported during awe-inspiring experiences. The world seems to fade away. The present moment expands. The increase in theta wave activity during awe is particularly interesting because it mirrors the brainwave patterns observed in experienced meditators. This suggests that awe may offer a readily accessible pathway to achieving states of deep relaxation and mental clarity, similar to those cultivated through years of meditative practice. Awe is not just a cognitive or emotional experience, it is also deeply embodied. When we experience awe, we feel it in every fiber of our being. We might get goosebumps, our heart rate might slow down, we might even feel a sense of lightness, as if we are floating. These physical sensations are mediated by the insula, a brain region that plays a key role in interoception. Interoception is the ability to sense what is happening inside our own bodies. It includes our awareness of our heartbeat, breathing, and other bodily sensations. The insula receives signals from the body and integrates them with other sensory information to create our subjective experience of the world. The activation of the insula during awe suggests that our physical sensations are an integral part of this emotion. These sensations contribute to the overall feeling of awe and make the experience more memorable and impactful. The transformative effects of awe are not fleeting. Regularly experiencing awe can lead to long-term changes in the brain. Studies have shown that people who frequently feel awe have increased gray matter volume in the hippocampus. The hippocampus is a brain region that is essential for learning, memory, and spatial navigation. This increase in hippocampal volume suggests that awe may help to protect against age-related cognitive decline. It may also enhance our ability to learn new information and form new memories. Furthermore, awe appears to promote the growth of new neurons in the hippocampus, a process known as neurogenesis. These findings highlight the remarkable plasticity of the brain and its ability to change throughout our lives. By cultivating awe, we can actively participate in shaping our brains and enhancing our cognitive abilities. The neuroscience of awe is a rapidly growing field. Each new discovery deepens our understanding of this complex and multifaceted emotion. What we are learning is that awe is not just a fleeting feeling of wonder, it is a profound experience that has the power to transform us at our very core. Awe expands our sense of self. It connects us to something larger than ourselves. It inspires us to learn, grow, and become better versions of ourselves. So how can we cultivate more awe in our lives? It's simpler than you might think. We don't need to travel to the ends of the earth or witness extraordinary events. Awe is all around us. It's in the everyday miracles of nature. It's in the boundless creativity of the human spirit. It's in the vastness of the universe and the intricate workings of a single cell.